Welcome to the IMAC online video series. This video is Basic Components of Aerobatics. Let's begin with lines. All lines are judged in relation to the true horizon and the axis of the aerobatic airspace. Horizontal and vertical lines are judged primarily on flight path. All figures begin and end on definite horizontal lines, and both must be present in order to earn a good grade. Omitting the horizontal line between figures results in a line omission deduction of 1 point from the preceding and the following figure. Interior lines. All lines that occur inside a figure have a beginning and an end that define their length. They are preceded and followed by a part loop. Except family 3 figures and some family 7 figures, interior lines do not have to be equal in length. Judges need to be familiar with the line length criteria for different figures and families. Rolls on interior lines. When rolls are placed on an interior line, the line segments before and after the roll must be of equal length. Judges should judge the symmetry of the line lengths within a figure, not the elapsed time taken to fly each segment. This difference in length versus elapsed time is most noticeable in figures where the rolls are placed on an upline. As the aircraft loses airspeed, the time it takes to fly a line after the roll will be greater than the time required to fly the line of the same length before the roll. If within a figure, 2 or more lines must be the same length, an observed variation is penalized by reducing the grade in the following manner. This is figure 14. Take a look at number 1. Any visible variation will be deducted 1 point. Figure 2. A 2-to-1 variation will have a 2-point deduction. Greater than 2-to-1 will have a 3-point deduction. Only one line is a 4-point deduction. No line before or after is a 4-point deduction. Having no lines in the figure is a 2-point deduction. Partial loops are integral to many other aerobatic figures, so it's necessary to discuss the loop and part loops before going on to other arrestee families. A loop or partial loop must have a constant, uninterrupted radius. Complete loops start and end in a well-defined line from horizontal flight. Part loops may begin in any other plane of flight. Part loops in any one figure may or may not be required to have the same radius. Thus, it is important of knowing the specific grading criteria for all arrestee families. The quarter loop in a vertical line, family 1 figure, need not match the radii. Take a look at figure 15. However, the top radius must not be a corner or a very sharp angle. This is figure 16. It must have a smooth, distinct, and constant radius. Loop rule deductions. Any variation in radius will have a 1-point deduction per occurrence. Take a look at the examples below. This example is a tight radius and it transitions to a large radius. This is an example of a large radius that transitions into a tight radius. You as a judge must decide when you see a radius change. Each time you see a radius change, you would deduct 1 point. Flight path without any radius, a straight line or flat spots, will result in a 1-point deduction per occurrence. Take a look at this example. This is the flat spot, exaggerated for illustration. Round corners. For any figure having more than one internal part loop depicted in the catalog as an actual round or looping element, all such part loops must have the same radius. An exception for all of family 8.8 double Humpty bumps. For those figures, the radius of the second half loop is not required to match the radius of the first one. thus the importance of knowing the specific grading criteria for all arrestee families. This is an example of round corners that must match. This is the double Humpty bump. This is the exception. These round corners do not need to match. Corner angles. For any figure having more than one internal part loop depicted in the catalog with a hard or corner angle, no such part loop is required to match the radius of any other part loop depicted in the same figure, with the exception of figures which must maintain a set geometric proportion. All of Family 3, Family 7.4.3, and 7.4.6 hesitation loops. This is an example of Family 3. These radius must match. This is an example of Family 7. Hesitation loops. These radius must match. Hard corners shown here in Figure 3 need not match. Hard corners in Family 5 shown in Figure 4 here, again, need not match.